First, we want to see how to graph sine of x with the baseline and the 5 key points technique. So first off, we're thinking about the baseline. The baseline right now is the horizontal axis. So later on in this chapter, we're going to be moving that baseline. So don't just say it's always on the horizontal axis. Say right now that the baseline is on the horizontal axis. Then we recognize that sine has a period of 2 pi. So we want to plot 2 pi. So we put down these 4 marks, and with the origin, that's the 5 marks. 0, pi over 2, pi, 3 pi over 2, and 2 pi. So our baseline right now is on the horizontal axis, and we plot the 5 locations on our baseline. And now we want to think about the 5 key points. And the 5 key points are, we mark where the max is, we mark where the min is. Our 5 key points are this, and this is how I say them: 0, up, 0, down, 0. You could say baseline up, baseline down, baseline. People usually get it when we say 0 up, 0 down, 0 up, 0 down, 0. And that they're putting the zeros on the baseline. So later on when the baseline moves, when you say 0, you're still plotting on the baseline. But those are the 5 key points. If I mark down 5 parts along the period, and I mark on the baseline 0, and then up 0, down 0, then once I have those 5 key points, all I have to do is connect them with a curve. You don't want straight lines, you don't want corners. That point makes it look like a corner, but at least it looks somewhat curved. And that's how you do sine with the 5 key points. So it's 0, up, 0, down, 0. And don't say 1 and minus 1, say up. And there's a reason for that that we'll run into later on in this chapter. Now we want to see how to do cosine with the baseline and the 5 key points. So here are 5 key points: 1, 2, 3, 4, 5. And the period for cosine is 2 pi. So this is 2 pi, this is half of that, pi, 3 pi over 2, pi over 2. And if you did like I did on sine, you could put down, this is my first one, this is my last, and then half, half, and half. And that works out really well too. Cosine has a max of 1 and a min of minus 1. Baseline is still on the horizontal axis. So cosine is different than sine in that it starts with up. So it's up, 0, down, 0, up. And then we connect them with a smooth curve. Cosine, baseline, 5 key points: up, 0, down, 0, up. Now we want to look at cosecant. And since we know what sine is, they're very similar in the way that you set up the 5 key points. Just a few little differences. We want our 5 marks on our baseline. Half of that, so it's still 2 pi, 3 pi over 2, pi, pi over 2, like this. And we know that sine has a max of 1 and minus 1, so we plot that too. Now first we recall what the 5 key points of sine are, which are 0, up, 0, down, and 0. And then we remember that cosecant is the reciprocal of sine. So really everywhere that there's a 0, we want to turn that into an asymptote. And then every part that's up stays up like this. And every part that's down stays down like that. The same 5 key points as sine, except for the zeros are turned into asymptotes. And then remember, sine would be up and down like this, but cosecant is that flipped with the asymptotes. Sine would be down like this, cosecant is down with the asymptotes. Secant is 1 over cosine. So our 5 key points, 1, 2, 3, 4, 5. We remember cosine has a max of 1 and a minimum of -1. Secant has the same 5 key points. Up, 0, down, 0, up. But for secant, because cosine is 0 here, secant, we turn it into an asymptote. Cosine would be positive here, so secant is up this way. Cosine would be negative here, so secant is negative this way. And cosine would be positive here, so secant is positive that way. For cotangent, it's important to recognize that the period is pi, not 2 pi. So we still have 5 key points, but we stop it at pi instead of 2 pi. And we also recognize that sine is in the denominator of cotangent. So our 5 key points are similar to those of sine, and we want to recognize how they compress into the period from 0 to pi. So if we were just doing sine, we would say 0, and then we would say 0 up, and then 0 for pi for sine. But we recognize that sine is in the denominator for cotangent, so it is actually asymptotes there. And we recognize that cosine is in the numerator for cotangent, and it is 0 at pi over 2, which means that cotangent is 0 at pi over 2. So this is 3 of our 5 key points. The other 2 are to help us remember which way it goes. And so what I want you to remember is that either remember that cotangent is always decreasing, which means that our second and our fourth key points, the second one's up and the fourth one is down. So you can see it as asymptote up 0 down 0, or asymptote. So it's the same sort of shape of sine, except for that we turn the first and the last into asymptotes and the middle stays as 0. And then you recognize that cotangent is always decreasing, so it comes down from positive infinity through 0, through that down point, and down to negative infinity. So however it works for you, if you want to remember 0 up, 0 down, 0, and then turn the ends into asymptotes, and then just twist it so it always is decreasing. If that works for you, that's great. For tangent, it also has a period of pi. We still need our 5 key points, but like cotangent, it only goes to pi instead of 2 pi. And we have to keep in mind that cosine is in the denominator for tangent. So here at pi over 2, that's where cosine is 0, which means that tangent is going to have an asymptote there. We also know that sine is in the numerator of tangent, and wherever sine is 0, tangent is going to be 0. So that's at 0 and at pi. Our second and fourth shape points are there to help remind you tangent is always increasing. So this one's up and this one's down. And notice that on cotangent and tangent, I didn't really plot where those are. It's not so crucial as just to plot them exactly, as just to help remind you that this one goes up and this one goes up. So tangent is always increasing. And so you can see its 5 key points are a lot like sines. Here's 0 up, 0 down, 0. And you just have to remember that the middle one is what splits into the asymptote. Now you should be able to do these graphs with the 5 key points very quickly, very easily. And you need to be fast at them. You need to know where those 5 key points are, because later on in this chapter, we're going to start moving these graphs all over the XY plane. We're going to shrink them down, we're going to spread them out, we're going to bring them up, make them tall, we're going to make them short, and we're going to move that baseline. All 6 of these graphs I've shown you, the baseline is on the horizontal axis. But then we're going to be moving that baseline. So you need to know this shape in relation to the baseline, and then when we move them, you'll still be able to graph them. So when you're doing this, practice on your homework, practice the 5 key points, and always say them to yourself. 0 up, 0 down, 0. And then make sure that you're modifying them accordingly depending on what the function is. And remember that not all of them start at 0, so keep that in mind. But learn those 5 key points and the baselines. And keep in mind that the 4 trig functions, sine, cosine, secant, cosecant, all have a period of 2 pi. Tangent and cotangent have a period of pi. So it's half that distance.